Hello, I'm Victor Chen. I'm a graduate student at Stanford University, and this work was done with collaborators from the University of Washington and Tsinghua University. Today I'll be talking about our paper, Understanding the Design Space of Mouth Microgestures. So more and more wearables are being developed to be worn on the head, like true wireless earbuds or smart glasses. This is conveniently bringing a lot of sensors to around the face. However, these systems lack intuitive, hands-free, eyes-free forms of interaction. For the earbuds and the smart glasses examples on the slide, the user still has to bring up their hand to interact with it, and this is why mouth microgestures are an interesting area to investigate. Before I continue, what do we actually mean by mouth microgesture? We define this as any deliberate action or movement involving any part of the mouth with the purpose of controlling some device. We've seen in many past papers that current sensing techniques are capable of recognizing various movements from different parts of the face. These are just a few examples, but they demonstrate that the mouth-based interaction is practical and viable. However, this design space hasn't been fully explored, and we seek to fill in this gap in knowledge. Our research questions cover what is the design space of mouth microgestures, and which microgestures do people prefer and find usable, and why? To even begin to understand this design space, we first had to determine what are the possible gestures that users could perform with their mouths. Our first study involved holding brainstorming sessions with participants to think of as many different gestures as they could. We had 16 participants generate 86 unique microgestures. After analyzing these 86 gestures, we developed a taxonomy to organize mouth microgestures along two axes. The first is by the main mouth organ used to execute the gesture, specifically the tongue, teeth, outer mouth, or throat. The second axis is the form of the gesture, or how it's represented. A gesture in the state category means that the goal of the gesture is to reach some kind of position of the mouth. The motion category means that the movement itself defines the gesture and carries its meaning, like sliding the tongue to the left. Lastly, acoustic refers to the gestures that are represented by some unique sound, such as clicking the tongue. And as you can see in the figure, the tongue category and the state category are the groups with the most gestures for each of the axes. And after collecting all of these gestures, we wanted to evaluate some high-level properties that could influence user preference. For this, we specifically looked at how physically and mentally demanding these gestures were. The question here was how to fairly compare such a wide variety of gestures. So we created three divisions based on how much information the gesture can convey. Then we can fairly compare within each category. 0-bit gestures are those that represent a single state, like tapping the tongue to the roof of your mouth. 1-bit are gestures that work in pairs and can represent two states, like sliding the tongue left or right. Multi-bit gestures are those that are variable and can represent more than two states. This would be like biting down with varying amounts of force. And so we conducted a pairwise comparison user study through Mechanical Turk. Participants would be shown several pairs of gestures and were asked to select the one they thought was more physically or mentally demanding according to the NASA TLX definitions. In the end, we were able to create a ranking from least to most demanding for both criteria, from which we selected these top 20 gestures. With this, we proceed into our third study, where we seek to find a practical gesture set by mapping the subset of gestures from the second study to tasks for common applications. This is the set of tasks we used that target different types of applications that are commonly used. So this was a remote Wizard of Oz study, and we recruited participants who were also involved in the brainstorming sessions of the first study. Participants were shown the before and after of these tasks and were asked to then choose and perform the gesture they would prefer to use from the provided subset. And we tested this under two contexts, sitting and walking to see if context made a difference in their preferences, and we also asked them other qualitative aspects of the gestures they used. For our results, a big question was which gestures were selected the most. On the left are selection counts for gestures that were used in a singular and standalone manner. You can see that the top 5 of these make up 70% of the choices. What's interesting here is that 2 of these top 5 are actually one side of a 1-bit gesture, like tap tongue to top teeth, while the other 3, and actually most overall, are 0-bit gestures. The middle plot shows the counts for gestures that were paired together for interactions that require discrete or continuous inputs, like increasing or decreasing the volume. The pair slide tongue to the left or right along the top teeth was greatly more preferred than the others. And on the right are the counts for the multi-bit gestures for continuous input. Something noteworthy here is the discrepancy between the preference of the most selected and the least selected of these 3, since the only difference is if the top or bottom teeth were used. With the data we had, we made some additional observations and answered some questions. The gestures that were originally 1-bit gestures were of particular interest, especially once they were separated into separate gestures. And we noticed some things about the symmetry of their preference. For gestures that were different only on whether the top or bottom teeth were used, there was some asymmetry with the top being more preferred. Gestures that had a left or right difference were more balanced. Another question was, how does context affect preference? This was in regards to the inactive sitting and active walking contexts we tested. Here we found no significance between the 2. So were the gestures easy to perform? We found that yes, they were. And this also validates the rankings on physical and mental demand that we established in study 2. Next, do users prefer the mouth microgesture or the baseline non-gesture interaction? We found that in most cases, the mouth microgestures were more preferred, but there were some where this wasn't so, like switching the camera on and off or increasing and decreasing the font size. What was interesting was that some participants commented that their preference to the baseline could have changed depending on the circumstance, like if their hands were dirty, which would have rated the mouth microgesture higher. And one more, which gestures are socially acceptable? Most of them were rated to be socially acceptable. However, again, there were some exceptions to this, which were the gestures that would be noticeably more visible to others when performed, like sticking your tongue out or opening your mouth by different degrees. Finally, these are some of the proposed design guidelines we summarize for future gesture designers. And I invite you to read the paper, which goes into more detail about other implications from our results. Thank you for watching, and please check out our paper.